My dear students, in this class we will discuss some more problems on continuity. Okay. Here is a question. Find all the points of discontinuities of this function. Find all the points of discontinuity of f of x, where f is defined by the first question is in this. The function f is defined by f of x is equal to 2x plus 3 if x is less than or equal to 2 and 3x minus 2 when x is greater than 2. Look here, they have defined the function in this way. F of x is defined as 2x plus 3 whenever x is less than or equal to 2 and it is 3x minus 2 when x is greater than 2, and we are asked to find all the points of discontinuity of this function. In other words, we have to check where and all this function is discontinuous, at which point or at how many points, which are all those points, which are those points where this function is discontinuous. That is what we need to test now. Okay. So now, before we check the continuity or the discontinuity of this function, first let us see how this function is defined. Whenever x is less than or equal to 2, let me consider, let us say this is the real line. Here we have 0, 1, 2, 3, 4 and so on. Okay. To the left side of 2, when x is less than or equal to 2, it is defined as 2x plus 3. 2x plus 3. And to the right side of 2, that is when x is greater than 2, the function is defined as 3x minus 2. So in this region, it is defined as 3x minus 2. Okay. What is the domain of this function? Domain of this function is the set of all real numbers. See, when x is less than or equal to 2, when I say less than or equal to 2, I mean interval minus infinity to 2, including 2. And when x is greater than 2, its meaning is 2 to infinity. So, in this interval, the function is defined as 2x plus 3, and in this interval, the function is defined as 3x minus 2, which means this function is defined everywhere. That means defined at each and every real points. Okay. So now, we need to find out where it is discontinuous. You just observe to the left side of 2, everywhere else. Everywhere it is defined as 2x plus 3, which is a polynomial function. And we have already seen in our last class that every polynomial function is continuous. So, to the left side of 2, that means whenever x is less than 2, this being a polynomial function is continuous. So, we don't find any point of discontinuity in the interval before 2. That is, in the interval, my open interval minus infinity to 2, there does not exist any point of discontinuity. Similarly, when x is greater than 2, the function is defined as 3x minus 2, which is also a polynomial, and every polynomial function is continuous. So, there also continuous, here also continuous. The only problem, if at all, I mean problem in the sense that only point of discontinuity, if at all exists, may exist at x equal to 2. Now you might think, sir, at 2 also it is a polynomial function. Yes, alright. At 2 also it is a polynomial function. At 2 it is defined as 2x plus 3. But at to the right side of 2 it is defined as 3x minus 2. There we have to check whether from left side and from right side when x approaches 2, whether that f of x is approaching the same quantity or not, that we must check. So, when a function is defined like this, it is very obvious that other than at x equal to 2, everywhere else it is continuous. Okay. So, we only need to check the continuity at x equal to 2. Everywhere else it is continuous. The only point of discontinuity may exist at x equal to 2. So, we need to check the continuity at x equal to 2. Okay. So, for that, I will find out left hand limit. left hand limit is equal to limit x tends to 2 minus f of x. That's equal to limit x tends to 2 f of x. X is approaching 2 from left side. When x approaches 2 from left side, x is less than 2. When x is less than 2, the function is defined as 2x plus 3. Apply the limit here, 2 into 2, 4 plus 3, that is 7. Then, right hand limit, that's equal to limit x tends to 2 plus f of x. That is equal to limit x tends to 2 plus. 2 plus means x is approaching 2 from right side. When x approaches 2 from right side, the function is defined as 3x minus 2. Apply the limit here, 3 into 2, 6. 6 minus 2 will give you 4. Left hand limit is 7 and right hand limit is 4. So, limit does not exist. Limit x tends to 2 f of x does not exist. If limit does not exist, then clearly we can say that the function is discontinuous at x equal to 2. So, the only point of discontinuity for this function is 2. Okay. So, finally you write one sentence. X equal to 2 is the only point of discontinuity. Okay. Let us look at the second question. Second function. Question is said, that is, find all the points of discontinuity of f of x where f is defined by. I will define now. F of x is equal to f of x is equal to mod x by x when x not equal to 0 and it is 0 when x is equal to 0. F of x equal to mod x by x when x not equal to 0 and is 0 when x is equal to 0. This is how they are defined. Okay. Let us elaborate this. When I write x not equal to 0, then arises two cases. One is x greater than 0 and the other one is x less than 0. So, I will split that x not equal to 0 into two cases, x less than 0 and x greater than 0. Mod x by x when x less than 0 and when x is greater than 0 also, it is defined as mod x by x. At 0, it is defined as 0. Okay. See, x not equal to 0 means either x is greater than 0 or x is less than 0. So, I have split it into two cases. Further, f of x equal to, just observe here, x is less than 0 means x is negative. When x is negative, how do we define mod x? When x is negative, mod x is nothing but it is defined as minus x. So, you have minus x divided by x which will be equal to minus 1. Then when x is positive, mod x is defined as x. So, x by x will give you 1. So, minus 1 when x less than 0 and 1 when x greater than 0. At 0, it is equal to 0. Okay. And now, look at this, minus 1. F of x is equal to minus 1 whenever x is negative and 1 when x is positive and 0 at x equal to 0. To the left side of 0, when x is negative, the function is defined as minus 1. Minus 1 is a constant function. Students, remember that every constant function is continuous. How? Let me explain. I will take one example of a constant function. Let me take f of x is equal to 2. I think you are already aware of the fact that what is a constant function. A constant function means every element of the domain has the same image. So, if I write f of x equal to 2, its meaning is that f of 0 is 2, f of 1 is 2, f of 2 is 2, f of 10 is 2, f of 100 is 2, f of minus 1 is 2, f of minus 3 is 2, etc. You put any value for x, you will see that f of x is equal to 2. So, the graph of this function looks like this. If I say this is 1 and this is 2, See, this is the graph of f of x equal to 2. You can, it starts at minus infinity and ends at plus infinity. So, for all real values of x, f of x is defined as 2 itself. Okay. So, by looking at this graph, it is very obvious that it is continuous. Okay. So, you can replace this 2 by k, where k is any real number. You put any real value for k. If that k is positive, then that line will be above x-axis. If that k is negative, then that line will be below x-axis. And if k is equal to 0, then we are talking about f of x is equal to 0. In other words, y is equal to 0. That is nothing but the equation of x-axis. Okay. So, f of x is equal to k, a constant function, is always a continuous function. Okay. So, every constant function is continuous. Remember this, which is an important point. Okay. Now, coming back to this problem. Here, when x is negative, function is defined as minus 1. When x is greater than 0, function is defined as 1. So, to the left side of 0, it is a constant function, so it is continuous. To the right side of 0 also, it is a constant function, which is continuous. But at 0, whether it is continuous or not, that is what we have to check. So, only point of discontinuity which may arise, which may exist, is at 0. So, at 0, we shall test its continuity. Okay. So, I want to test the continuity at x equal to 0. For that, left hand limit x tends to 0 minus f of x. When x approaches 0 from left side, when x approaches 0 from left side, means when x is less than 0, the function is defined as minus 1. Limit x tends to 0 minus 1 is equal to minus 1. Then right hand limit, that's equal to limit x tends to 0 plus f of x. That's equal to limit x tends to 0. X is approaching 0 from right side, that means x is greater than 0. Whenever x is greater than 0, the function f of x is defined as 1. So, this is equal to 1. Left hand limit is minus 1 and right hand limit is plus 1. So, limit does not exist and obviously it is a point of discontinuity. In other words, f of x is discontinuous at x equal to 0. Okay. Now, actually this is a very well known function. What this example is very well known to you. I think most of you must have understood by now that this function is nothing but the sinum function. At the 0, it is defined as 0. When x is positive, it is defined as 1. When x is negative, it is defined as minus 1. So you can see at a 0, it is defined as 0. And when x is positive, it is defined as 1. When x is negative, it is defined as minus 1. You can see that this line does not touch y-axis. There is a small gap between this line and y-axis. You can zoom in and check. Okay. Similarly, here also there is a small gap. So this is discontinuous at x equal to 0. Everywhere else it is continuous. Okay. So for this question, the answer is 0. At 0, this function is discontinuous. And or you can also write that 0 is the only point of discontinuity. Okay. Then let us look at the next question. Question is same. Here also you have to find the point of discontinuity of the given function. F of x is equal to x plus 1 whenever x is greater than or equal to 1 and x square plus 1 when x is less than 1. So, for this function we have to find the points of discontinuity. Again, to the left side of 1, function is defined as x square plus 1, which is a polynomial function, so it is continuous everywhere. And to the right side of 1, x, it is defined as x plus 1, there also it is a polynomial function, so it is continuous. So, we only need to check the continuity at x equal to 1. Okay. So, left hand limit, that is equal to limit x tends to 1 minus f of x. That's equal to limit x tends to 1. X is approaching 1 from left side. X is approaching 1 from left side. There the function is defined as x square plus 1. That's equal to, apply the limit now. Take x is equal to 1 here. 1 square is 1 plus 1, that will give you 2. Then right hand limit, that's equal to limit x tends to 1 plus f of x. It means x is approaching 1 from right side. When x approaches 1 from right side, means whenever x is greater than 1, the function is defined as x plus 1. Apply the limit here, we get 1 plus 1, which is 2. So I can write limit x tends to 1, f of x is equal to 2. What about f of 1? What is the value of f of x at x equal to 1? At x equal to 1, this is what we have to consider. At x equal to 1. So putting x equal to 1 will give you 1 plus 1, which is 2. Okay. So here it is very evident that limit x tends to 1 f of x. Limit x tends to 1 f of x is equal to f of 1. Therefore, I can say f of x is continuous at x equal to 1. Continuous at x equal to 1. Okay. So, and it is obvious that it is continuous everywhere else. It suggests that f of x is continuous everywhere. Continuous everywhere. When I say everywhere, its meaning is at every real number. Okay. So, f of x is continuous everywhere. Now look at what the question they have asked. They have asked us to find all the points of discontinuity for this function. And we have observed that this function is continuous everywhere. So then what is the answer for this question? All the points. Okay. What are the points? There is no point at all. So this is continuous everywhere. Hence, f of x has no point of discontinuity. Since this is continuous everywhere, this does not have any point of discontinuity. Okay, f of x has no point of discontinuity. Is it clear? Okay. Let's go to the next question. F of x is equal to x square minus 3 if x is less than or equal to 2. X square minus 3 if x is less than or equal to 2. Sorry, x cube minus 3. And it is x square plus 1 if x is greater than. Okay. F of x is defined as x cube minus 3 if x is less than or equal to 2, and x square plus 1 if x is greater than 2. Question is saying find all the points of discontinuity. Okay. So now we only need to test the continuity at x equal to 2, because that's the only point where a point of discontinuity may arise. Okay. So I don't think why it is continuous everywhere else. Should I explain that? Yes, good. No. Okay. So now we will test the continuity at x equal to 2. So for that, I take left hand limit. Left hand limit is limit x tends to 2 minus f of x. That's equal to limit x tends to 2. X is approaching 2 from left side. When x is approaching 2 from left side, its meaning is that x is very close to 2 but less than 2. When x is very close to 2 but less than 2, there the function is defined as x cube minus 3. That's equal to. Here if I put x equal to 2, we will get 2 cube, which is 8. 8 minus 3, that is 5. Then right hand here, that's equal to limit x tends to 2 plus f of x. That's equal to limit x tends to 2 f of x. X is approaching 2 from right side, means x should be greater than 2. In that region, the function is defined as x square plus 1. Apply the limit, that is putting x equal to 2 will give you 2 square plus 1, that is 4 plus 1, which is equal to 5. So left hand limit is equal to right hand limit. From there we can say limit x tends to 2, f of x is equal to 5. Then we need to find out what is f of 2. F of 2, when x is less than or equal to 2, f of x is defined as x cube minus 3. So at a 2, putting x equal to 2, you get 2 cube minus 3, that is 8 minus 3, which is 5. So limit x tends to 2, f of x is equal to 5, f of 2 is also equal to 5. So we can write that limit x tends to 2, f of x is equal to f of 2, hence f of x is continuous at x equal to 2. And obviously it is continuous everywhere else, hence f of x is a continuous function throughout its domain. What is the domain? Domain is the set of all real numbers. Everywhere it is continuous. Hence, for this function also, there is no point of discontinuity. Okay, let's move to the next question. F of x is equal to x power 10 minus 1 when x is less than or equal to 1, and x square when x is greater than 1. Okay. Here also we want to find the points of discontinuity of this function f of x. So obviously we need to test the continuity at x equal to 1. At x equal to 1 you check whether it is continuous or not. Everywhere else it is continuous. So 1 is the only possible point where the function may be discontinuous. Okay. So at x equal to 1 we want to test. I will find out left hand limit. Limit x tends to 1 minus f of x. That's equal to limit x tends to 1, x is approaching 1 from left side. When x approaches 1 from left side, means x is less than 1, the function is defined as x power 10 minus 1. X power 10 minus 1, apply limit here, 1 power 10, that is 1 minus 1, we get 0. Then right hand limit, that's equal to limit x tends to 1 plus f of x. That's equal to limit x tends to 1 f of x. X is approaching 1 from right side. When x approaches 1 from right side, f of x is defined as x square. So apply limit now, 1 square, which is equal to 1. Left hand limit is 0, right hand limit is 1. So limit x tends to 1 f of x does not exist. If the limit does not exist, then the function is discontinuous at that point. So you can write x equal to 1 is the only point of discontinuity. Only point of discontinuity. So we can say that this function is discontinuous at x equal to 1 and continuous everywhere. Okay. Now let us go to the next set of problems. Next question is discuss the continuity of f. Discuss the continuity of f, where f is defined by. This question is common for the next few problems. In that, the first function is f of x is equal to 2x when x is less than or equal to 0. 2x when x is less than 0. and it is 0 if x is greater than or equal to 0, less than or equal to 1, and 4x if x is greater than 1. Okay, so this function we are asked to discuss the continuity of f. Discuss the continuity of f means throughout the domain what happens to this function, in which interval it is continuous, or at which point it is discontinuous. All those things we have to check, we have to discuss. Okay. So here the function is defined in three different ways. Whenever x is negative, it is defined as 2x. When x is between 0 and 1, it is defined as 0. When x is greater than 1, it is defined as 4x. Okay. So you just observe here. This is 0, 1, 2, 3, and so on. And this is minus 1, etc. When x is less than 0, means minus infinity to 0. Then it is defined as 2x. Then between 0 to 1, it is defined as 0. Then from 1 to infinity, it is defined as 4x. Okay. So from minus infinity to 0, it is defined as 2x. 0 to 1, it is defined as 0, and 1 to infinity, it is defined as 4x. So we can say that the function is continuous in this interval, minus infinity to 0, it is continuous, and open interval 0 to 1 also, it is continuous. Then from 1 to infinity also, it is continuous. Why it is so? See, in this interval, minus infinity to 0, the function is defined as 2x. 2x is a polynomial function, and as we know that every polynomial function is continuous, so this is continuous in this interval. Then between 0 to 1, f of x is defined as 0. 0, it's not a polynomial function, which is a constant function. 0 is a constant function, and we know that every constant function is continuous. So it is continuous in this interval. Then in this interval, 1 to infinity, open interval 1 to infinity, f of x is defined as 4x. 4x is another polynomial function, so that is also continuous. Hence, the points of discontinuity, there are only two possibilities. One, at the 0, because at the 0, to the left side of 0 and the right side of 0, function is defined in two different ways. Again, to the left side of 1 and to the right side of 1, function is defined in two different ways. So the only points of discontinuity may arise at 0 and at 1. Those are the only 2 points where we need to check the continuity. Everywhere else it is continuous. Okay. So now before I check at 0 and 1, if this question is asked in the exam, then what we should write is the domain is R. So here they have not asked us to check where it is continuous or which point, what are the points of discontinuity. The question is to discuss the continuity of this function. So discuss means you have to discuss it everywhere. I mean, starting from minus infinity to plus infinity, what happens in which interval, where it is continuous, where it is discontinuous, all those things you have to write in detail. The domain is R. Okay, fine. Then in minus infinity to 0, in this interval, minus infinity to 0, f of x is equal to 2x, a polynomial. Okay, I'll write f of x equal to 2x is continuous. Is continuous, being a polynomial function. So since it is a polynomial function, it is continuous in this interval. Okay. Then next, in 0 to 1, I have taken open interval 0 to 1. Though at 0 and at 1 also it is defined as 0, because at 0 and 1 I have to check whether it is continuous or not, so I have not included it. In 0 to 1, f of x is equal to 0 is continuous. Why it is continuous? Because f of x equal to 0 means a constant function. We already know that every constant function is continuous. So f of x equal to 0 is continuous, being a constant function. Since it is a constant function, we can directly say that it is continuous constant function. Okay. Then I will choose this interval x greater than 1. X greater than 1 means 1 to infinity. In 1 to infinity, in this interval, f of x is defined as 4x. F of x equal to 4x. So 4x is also a polynomial function. Therefore, this is continuous. Continuous being a polynomial function. Okay, this is what you are trying. Well, so we have seen minus infinity to 0, 0 to 1 and 1 to infinity. In these intervals, it is continuous function. F of x is a continuous function. Now, what we have not considered is the 2 points 0 and 1. We shall verify the continuity of this function at 0 and at 1. At x equal to 0, let us do one thing. Left hand limit x tends to 0 minus f of x. That's equal to limit x tends to 0. When x approaches 0, from left side, function is defined as 2x. 2x, apply limit 2 into 0, that will give you 0. Then right hand limit, that's equal to limit x tends to 0 plus f of x. That is equal to limit x tends to 0 f of x. X is approaching 0 from right side. When x is approaching 0 from right side, f of x is defined as 0. Apply the limit, we get 0. Then, so we can write limit x tends to 0 f of x is equal to 0. What about f of 0? At a 0, how do we define this function? We define it as 0 itself. Limit x tends to 0, f of x is 0 and f of 0 is also 0. Therefore, f of x is continuous at x equal to 0. Okay? Then, at x equal to 1, we shall test now. Then, left hand limit, that is equal to limit x tends to 1 minus f of x. That's equal to limit x tends to 1. X is approaching 1 from left side. Here is 1. X is approaching 1 from left side. There, f of x is defined as 0. So, this will give you 0. Then, the right hand limit is equal to limit x tends to 1 plus f of x. That's equal to limit x tends to 1. Right hand limit, x is approaching 1 from right side, means x is greater than 1. Then the function is defined as 4x. Apply the limit, 4 into 1 is 4. Left hand limit is not equal to right hand limit. Hence, we can say limit x tends to 1 f of x does not exist. If the limit does not exist, we can directly write that f of x is discontinuous at that point. So, the conclusion is that this function is discontinuous at x equal to 1 and everywhere else it is continuous. Already we have seen earlier that in the open interval minus infinity to 0, open interval 0 to 1 and open interval 1 to infinity it is continuous, and at a 0 it is continuous, at 1 it is continuous. So, the final answer we should write in this way. F of x is continuous in R minus 1. Continuous in R minus 1. It's saying yes, it is continuous in the set of all real numbers except at 1. So at 1 it is discontinuous, everywhere else it is continuous. Okay. Let us look at the second question. Question is same, we have to discuss the continuity of the function. F of x is equal to 3 if x is between 0 and 1. 3 if x is greater than 0, less than or equal to 1. And it is 4 if x is greater than 1 but less than 3. Greater than 1 but less than 3. And it is 5 if x is greater than or equal to 3 and less than or equal to 10. Okay. So here f of x is defined as, second question, f of x is defined as 3 whenever x is in the closed interval 0 to 1. And it is defined as 4 when x belongs to the open interval 1 to 3. And it is 5 when x lies in the closed interval 3 to 10. So the domain of this function is closed interval 0 to 10. This function is defined in this interval. So we only need to check what happens in this interval. Everywhere else what happens, we are not bothered because the domain of this function is only the closed interval 0 to 10. Okay. So now by looking at this only, you can identify that the points of discontinuity may arise at 1 and at 3. Because you see how it is defined. Here I take 0, 1, 2, 3, 4 and so on till 10 because we are only talking about 0 to 10. From 0 to 1 it is defined as 3. From 0 to 1 it is defined as 3. From 1 to 3 it is defined as 4. From 1 to 3 it is defined as 4. And from 3 to 10 it is defined as 5. Okay. So to the left side of 1 and to the right side of 1 function is defined in two different ways. Similarly, to the left side of 3 and to the right side of 3 function is defined in two different ways. So these two may be the points of discontinuities. But everywhere else it has to be continuous, because if I only choose this, f of x is equal to 3, which is a constant function. The constant function is continuous everywhere. Similarly, f of x equal to 4 is another constant function which is also continuous. And f of x equal to 5, this is one more constant function which is also continuous. So the only points of discontinuity may arise at 1 and at 3. So we shall test the continuity at those 2 points. Okay. So first at x equal to 1. Left hand limit. Left hand limit is limit x tends to 1 minus f of x. That's equal to limit x tends to 1. X is approaching 1 from left side. When x approaches 1 from left side, that means x is less than 1. There it is defined as 3. Apply the limit, then will be 3. Then right hand limit. That's equal to limit x tends to 1 plus f of x. That is equal to limit x tends to 1. X is approaching 1 from right side. X is approaching 1 from right side. X greater than 1. There the function is defined as 4. Okay, after applying the limit, this is what we get. So left hand limit is 3, right hand limit is 4. So limit does not exist. Limit x tends to 1, f of x does not exist. Does not exist. And obviously at 1 the function is discontinuous. Then we shall test the continuity at x equal to 3. At x equal to 3. So here left hand limit is equal to limit x tends to 3 minus f of x. That's equal to limit x tends to 3. X is approaching 3 from left side. When x approaches 3 from left side, in that region the function is defined as 4. So this is equal to, when I apply the limit here, we get 4. Then right hand limit, that's equal to limit x tends to 3 plus f of x. That is equal to limit x tends to 3. X is approaching 3 from right side. X is approaching 3 from right side means x is very close to 3 but greater than 3. There the function is defined as 5. Apply the limit, we will get 5. So left hand limit is 4, right hand limit is 5. Hence limit does not exist. Limit x tends to 3 f of x does not exist. When the limit does not exist, it is very obvious that the function is discontinuous at x equal to 3. So what we are seeing here is the function which is defined in this interval 0 to 10, it is discontinuous at 1 and at 3. Everywhere else it is continuous. So you can write it in this way. F of x is continuous in 0 to 1 union 1 to 3 union 3 to 10. Okay, in this interval it is continuous. And discontinuous at x equal to 1 and x equal to at 1 and at x equal to 3 it is discontinuous, everywhere else it is continuous. Now some of you may be thinking, sir, why did you choose 1 and 3 only? There are still some more integers like 2, 4, 5, 6, etc. Okay, why did I not select them is because, say for example 2. To the left side of 2 and to the right side of 2 function is defined in the same way. So there is no point to check the continuity, it is continuous, obviously. Similarly, say at 4, to the left side of 4 and to the right side of 4. So if I choose one small open interval containing 4, to the left side of 4 and to the right side of 4, function is defined in the same way. So we need not consider the point 4. Okay, so only point needs to be considered is 1 and 3. Okay, so this is the answer for this question, that is, it is continuous in this interval and discontinuous at 1 and at 3. After looking at the solution of this question, some of you might get one doubt. Okay. The doubt is that what happens, sir, at 0 and at 10? Why don't we consider them? It's a very good doubt. I'll explain what happens at 0 and at 10. See, when the function is defined in a closed interval, first I will give a general example, then I will come to this particular problem. Let us say function is defined in a closed interval A. Then we say this is continuous, or sorry, I'll take this is A. Closed interval A, I am choosing. Let C be an interior point of this. C is an interior point. C is anywhere inside this interval. Okay. F of x is defined in this interval. Then when I say it is defined in this interval, obviously it is defined at C also. Then to say that function is continuous at C, we must write left hand limit is equal to right hand limit is equal to functional value. Right? So, in other words, limit extends to C minus f of x is equal to limit extends to C plus f of x is equal to f of C. When it is defined in a closed interval, and if C is the interior point, then to say that f of x is continuous at C, we must prove that left hand limit is equal to right hand limit is equal to functional value. This is well known to you. Okay. Now, coming to this point, the end points of this interval, A, first I will choose here. At A, I want to check whether it is continuous or not. We say f of x is continuous at A. In general, we say f of x is continuous at A if left hand limit is equal to right hand limit is equal to the function value. However, if A is an end point of this interval, or should I say the starting point of this interval, at A we cannot find out left hand limit at all. Okay, because to the left side of A the function is not defined at all. If the function is not defined at all, then don't think that left hand limit does not exist. Okay, so they don't think that it must be discontinuous. There, how do we define continuity? Is we will see the right hand limit, that is, we will look at this limit extends to A plus f of x. Check whether it is equal to f of A or not. If this happens, okay, limit extends to A plus f of x, that is, x is approaching A from right side, because x cannot approach A from left side, because in this region f of x is not defined at all. I hope you are following. Okay, see, x is approaching, x can only approach A from right side, x cannot approach A from left side. So there is no question of finding left hand limit. So here, if a right hand limit exists and if it is equal to the functional value, then we say f is continuous at x value. Okay. Similarly, at b, there we cannot find out right hand limit because to the right side of b the function is not defined at all. So there we can only find out left hand limit. So at b, limit extends to b minus f of x should be equal to f of extends to b minus f of x is equal to f of b. That is, if left hand limit is equal to the functional value, then we say that the function is continuous at b because there right hand limit does not exist. Okay. So in general, this is the definition for continuity. We say if this happens, then we say that the function is continuous at c for any general point. But if you are looking at the endpoints of a closed interval, then a is the initial point or the starting point of this closed interval. There it will be continuous if right hand limit is equal to functional value. Similarly, b, which is an endpoint of the closed interval, there it is. We say that it is continuous at b if the left hand limit is equal to the functional value. Left hand limit is equal to the functional value. Okay. So by looking at this, we can see that at 0, what happens? We can only find out right hand limit. Right hand limit is 3. Functional value is also 3. F of 0 is equal to 3. So it is continuous. Then at 10, we can only find left hand limit. To the left side of 10, the function is defined as 5. At 10 also, it is defined as 5. So the function is continuous at x equal to 5. Okay. This is just to clear your doubt only. Need not write in the examination. These things you need not write. If this question is asked, just write in this much is enough. Okay. Thank you, students. I hope you have understood. With this, I'll stop today's class. Thank you.